I had this video I wanted to make really quick. So I wanted to, one, talk about past, present, future, and then overlaying extrapolation. Two, alien starshot. Three, rounded square simulations, and how there could be pattern-based simulations, like a Mandelbrot. Like you can base it off of fractals or patterns of fractals, not necessarily like they're mathematical in nature, but I'm saying you don't even have to know mathematics to actually make something like that. Four is wavelength problem. Five is color. It's just a thermal effect, and then six log wave functions, logarithmic. I'm actually going to pull a reverse and talk about this one first, because look, people have a hard time with this. So it's like, okay, this is a number line. This is a number line. I'm saying if you were to turn this to the side, you'd see that. See, it's hard, but there's. Imagine the z-axis is coming at you. You see what I'm saying? So perhaps I need to draw, because it's really like this. I wasn't the best at drawing perspective, I'll be honest. Ironic, since I think in shapes. But I'm saying, see, there was this whole plane that you couldn't. And it just appears diagonal when I draw it like that. But I'm saying if I draw it forward facing, then you're just only ever going to see you're only going to ever see this face of it. You're not going to see how that face incorporates with this face and how it's like a whole complex like geometry or whatever. Like you're not going to see the multiple. I'm saying in any, you just can keep adding them and keep adding them and adding them. I'm saying, but eventually it's going to coalesce to this dense like sphere of information, because that's what interactions seem to do. It's just at the basis of interaction, but I'm not even going to go that far yet. So imagine this is your sensor point, and you're graphing a logarithmic wave function that like approaches zero, but doesn't quite get there from each side. It's like the Atari symbol. You see what I'm saying? I'm saying, but basically you can cheat logic and be like, well, I know if I do this on this side, it's the inverse. It's literally the inverse. You can cheat logic by saying, okay, it doesn't even touch. But by understanding magnetism and how magnets may repel across dimensions, we can basically draw an imaginary line here and say, okay, in an infinite amount of time, they will eventually theoretically touch if you're using quantum entanglement. I'm saying you can like round off your logic, like to save space. Your simulation wouldn't even have to be that big if you already understand wave functions. It could be entirely based off waves and magnetism. See what I'm saying? You could be in a rounded simulation just to save space. Get it? Save space. Okay. Color is just a thermal effect. Because, yeah. Well, M theory be like... if you had like an 11th dimensional string brain thing, then... And, okay, you know red dwarfs are of the... I would say primarily M spectral type. So it's their spectral type. I'm saying it's a thermal effect because if you perturb it enough, if you spin it up enough, if you interact with it enough, it'll coalesce. And if you understand magnetism, how magnets work, so you had, well, really you have to understand polarity, and And then magnets can work like batteries, really. Right? You just match up the sides that connect and the sides that don't. And I'm saying you can basically run currents through them. That's how batteries work, right? I'm saying, what's the difference between magnetism and electromagnetism? You know what I'm saying? I'm saying the speed of light is, we measure it as what we can see visually. So, I mean, white is the brightest thing we can see. So that's probably our highest consideration, I'm assuming. Because we know infrared is this wavelength. Well, I'm saying basically we have a wavelength problem. See, I'm still going up the ladder, the Jacob's ladder. It's a thermal effect, which I basically proved because that's what spectral types of stars are. Stars. It's a thermal effect of. This is perhaps what you may have heard at any point in time ever referred to as something similar to thermal quench. Basically, it's the ability for things to increase on a macro scale and then basically decrease on a micro scale, and not necessarily in scale, like this ratio either. I'm saying basically it can also decrease in other ratios as well. I'm saying you can mess with microwaves. You can mess with waves to basically turn things different sizes. So like I was saying, imagine if this is like some sort of spaghetti. I'm saying dependent on your understanding of what scale you use. So you can use scale 1 or scale 2. Right? I'm saying you appear to be violating causality, but not really. Because you're bending light faster than it can react to your bending of it, which is essentially what this is essentially what a black hole does. So it's a super dense singularity that can, if light was coming at it like a star, it could start bending. Well, it could start like pulling in the plasma and all the gases and all the elements, and it'll start gravitationally pulling it as it drags it, right? So it's ever so slightly adding to its mass, and it's basically practicing Mortal Kombat and saying, "Get over here." You know, you got within the zone. You're getting pulled in now, and this is what the accretion disk would be, dependent on where you're looking at it from and how much it has accreted. I'm saying, so basically this is the time breaker, because we measure time as how long it takes light to travel. But what is light if not just photons of detectable wavelength? You know what I'm saying? That you can use thermodynamics to heat up to a brightness, or you can cool down. Which, by the way, we also have to take into account not only light year distance, but also when people start, you have to use parallax at some point to basically be like, okay, well, actually, this is this far away. So there's a difference between apparent and absolute. magnitude, right? Something like that. I'm saying, well, apparent to who? Who's observing it? A Homo sapiens? You know what I'm saying? Or a cat, or an alien, or anything in between. What's apparent? I'm saying this is where we run into our wavelength problem. It's dependent on perception. Because, okay, well, if you don't believe me, take a colorblind person and tell them to look at everything in space and what the magnitudes of things are. They probably won't be able to tell color, right? So they can't probably even conceive of the dimensionality that this possesses. It's just a dimension that they can no longer see. So it's like literally taking like an entire dimension of understanding out. And it's like, well, they're no dumber. There's something they can't perceive there. And I'm saying, well, what drives a lot of perception? Well, that's a multi-layered question. Societies can. I'm saying, but if you're an animal on a planet, then you probably don't have much of a society besides like a local community. I'm saying it's what plays a big role of perception. So whatever the circumstances of your birth, which for many on Earth I would say is DNA. That's you know ribose nucleic acid, I think, something like that, RNA. I'm saying whatever, it's just genetics. It fits under the umbrella term of genealogy or genetics. And I'm saying, but once you add environment, which is just really interaction in disguise. So you basically you're self-contained person right now, and you're just coming into the world and you're deducing your environment by interacting with it. This is what a consciousness starts doing. This is how it develops its perception. So, there's our wavelength problem. It's perceptual. Are you bringing a colorblind person into space, or are you bringing a person or animal that can perceive more than you can perceive into space? You see what I'm saying? I'm saying once you understand how gravity is basically a series of interactions across a period of time, once again, once you understand that gravity is just interactions plus time, is how I'll just briefly characterize it here. So, approximately. Because I'm saying everything's an approximation at some point. Because you can always dig deeper and learn more. Like it kind of never stops. It just gets, I wouldn't say infinitely harder, but it's well, let me put it this way. Plus time. So hold on. So yeah, once you understand that gravity can basically cause an effect known as, I'm sure you've heard this when black holes are talked about, especially when event horizons are talked about, spaghettiification. which is essentially what this thermal quench is. It's you're dragging out this plasma, you're dragging out this matter, you're dragging out this mass, you're dragging out these photons. You're any semblance of oneness it used to contain as a separate entity is now being integrated and being stretched so thin that even our macro linear perception of time doesn't matter anymore. Like it starts taking infinitely long because we're just if you think it's like, okay, suppose you're using something like the Gregorian calendar and you're just going down the list. You're like, well, it's just going to take as long as it's going to. But I'm saying someone who already sees the patterns. Remember when I said pattern-based simulations, like fractals? I'm saying as soon as they can start counting, they can go ahead and they could just give you the rest. I'm saying you may always start at 1, or you may even start at 0. I'm saying, but once you start noticing a pattern, you can So I'm saying, what if there was a civilization where their time scale was divided like this in their experience? I'm saying from a form of life that experience, well, see, that's what I'm saying. And I'm saying at the end of the day, there's some slight objectiveness to where things should have ended up. Because if you think about it, fractals are it's just doing time like this. So saying, that's basically what it is. That's basically what a pattern-based simulation would be. It would be rounded simulation. It would be like, well, this doesn't need to be calculated out until it's explored, right? This part doesn't need to be known until it's observed. I'm saying our observation is an interaction in of itself on the quantum level. Personally, I do think it's our destiny to go out and observe things, right? That's just what interaction is. But okay, once you understand spaghettification, it's taking things and it's just stretching them, right? So I'm saying, but if you could zoom in, you might see that there's still yet more deviation. I'm saying, and if you still zoom in, on that, I'm saying, even though this basically looks like this, but it's like, okay, well, you zoomed in on this and created this, and you zoomed in. So you basically found, okay, let's just say call this, if you want to start inverting every, and saying the cutoff is about at the, oscillation points. And like, you can be as precise or as imprecise. That's what approximation is. It's just saying it's about this. I'm saying that's what I don't want to go in, because quantum basically keeps, adding, like, it's like adding to pi, like I kept saying. It's like you want to be linear about it and just keep. I'm saying it's going to take infinitely, it's going to seem like it takes infinitely longer to understand the next. But I'm saying that's just what interaction is. We're unwittingly doing quantum mechanics this whole time by trying to deduce our reality. by even entertaining the thought experiment that we could be in a simulation, we just thought of square simulations. But I'm saying, what about exotic simulations? You understand what I'm saying? So I'm saying, okay, now understand that time is just our measured understanding of what we can detect. But I'm saying, what if we couldn't detect past here because we just didn't have strong enough technology? I'm saying, using this extrapolation technique, we can basically simulate, well, we can make these brown realities where we project, and I'm saying this is what we're doing by creating stories. But because we're interacting with new material and new matter, and we're coming up with new ideas. So this is where, I guess, stories fit in, because this would technically be fiction, right? You're like, oh, your extrapolation of the data is nothing more than fiction. And it's like, correct, because it hasn't happened yet. But I'm saying, what you can do, despite this part not happening, is you can use this extrapolation of your data, and you can use this past understanding, and you can kind of dial it back and dial this forward to basically re-examine. You can cross-check. I'm saying, even from basically almost no complexity at all, you can add complexity. It just takes a long time to do it. You just basically have to check back and forth. It's how fast is your refresh rate? Now I understand. You see what I'm saying? It's just, it has a little bit more meaning to it. By definition, I'm saying, now you're to the point where you're giving waves meaning, because I'm saying, if you were to zoom in on this wave, what you would actually detect is like, it's just tiny particles that I'm saying, but from so far away, it might as well be a wave. I'm like, that's as good as graphing a wave function on a piece of paper. You're just graphing wave functions at this point. That's all it becomes at this point. And I'm saying the best way to do it is to round off your logic by looking at the Mandelbrot. So you can ask, what experiences does a Mandelbrot, because it just goes on forever, right? If you ever seen those videos. And it's like, well, it seems to happen at moment per moment, right? Because you could speed up the video or you could slow it down. You could speed up the video or you can slow it down. You could speed up the waves or you could slow them down. You can basically violate causality here once you understand this. Once you understand that time doesn't have to be linear. It can be in epochs and ages and stuff like that. Because we only deduce time off of the visible, the perceivable. And I'm saying that breaks down at quantum. So I'm saying this is no different from a localized event horizon of the greater effect of a big rip scenario. Because I'm saying, well, when a big rip happens, if for some reason there are no conscious observers and there's like almost near exact physics in a same universe, I'm saying you can extrapolate out and you can fantasize about, okay, what if absent from some variables we don't know? Well, then you might start to like consider all these different paths or realities, and then you start to solidify which one's most likely, right? Because you just can't. This is basically what happens, and it's whatever. And I believe this is what happens when you try the double slit experiment and it places it on the board. I think there's some sort of magnetic force of the universe as explained with electromagnetism. because it's like, okay, where does the electric force come from? Where does the magnetic force come from? I would say it's interactions. It's dimensional interactions that either repel or perturb things and coalesce them in an infinitely dense point into a particle, and that particle can be scaled up to make what would be a macro particle, or I guess some sort of planetoid. It doesn't have to be completely spherical. It could be an asteroid type of planet, like one that's not completely. I'm saying just because things eventually coalesce into spheres doesn't mean like it's a thing of time. When are you observing it? What wavelength are you observing it in? Like, so I believe this is. You should look up. Oops, double slit experiment. The double slit experiment. It'll basically show you that on an imperceptible level, waves are also just a bunch of particles that I guess you could say haven't come into existence yet. From like a technical standpoint, that's what I'm saying. Using the Large Hadron Collider to basically accelerate particles and make them collide. You're basically forcing these interactions faster and faster to create these new particles into existence. And I'm saying you don't have to do it through that method. You can. This is what it does. But you're essentially just adding another number to pi. Okay.
Yeah, I know.
Don't worry. Science eventually tells you how to be a good person and how not to complain about everything all the time. Let's see. So now that we solved that, let's or just at least hypothesize. I'm saying it happens at moment per moment. So it's just really how you define time. I'm saying you can think of time in between time. And I'm saying it's no different from just ultimately at the end of the day asking, which dimension are you on? How much density or mass is your information or understanding or interaction? How many interactions have you had per rate of whatever? How much of life have you experienced? That's kind of your age. So something I did want to point out is that I'm saying you could see patterns, and they're not the same number. They don't have the same outcome. But well, I forgot the exact. Okay, so from this we get around 46-ish. I know there's actually more to the number, and then around 42-ish. So I'm saying, even if you're stuck, even if you can't count higher than 5, really, but you keep stacking complexity and keep trying, you'll oscillate between. Generally, you could say, because you could just take the human mindset, since we know about that so much, and just extrapolate it and be like, okay, when you say you're a third dimensional being, what do you really mean? Well, it means you could be of this age in human years, which human years for the longest time are just Earth years in Gregorian calendar. So yeah, if you're a third dimensional, do you see what I'm starting to say? I'm saying around this time you can expect it, if you round off your logic and be like, it kind of makes sense. You could say, okay, you can expect, this is how they modulate like IQ. You know what I'm saying? They always try to keep it up with like the standard deviation, like a wave function, right? Basically, I don't think I've said much wrong here. Like, I'm saying you can even treat chromosomal sets and a standard deviation of what you would expect. And I'm saying, by the way, not only the standard deviation exists, but other things exist. And I'm saying, if you guys ever seen the Dunning-Kruger, I'm saying you can basically invert that. You see what I'm saying? And the oscillations can occur much faster. I'm saying it can be a pattern, just like Mandelbrot. Why are we saying we have to be in a simulation like this? In a sense, it could be based off of anything. That's why I maintain that and using any methodology, you can deduce reality. Meth head's live reaction. Yeah, if you're a meth head, you probably, like, neurochemically, you've kind of cheesed yourself to being like, in Gregorian Earth calendar years, you're like 50 years old with the human brain, how it understands time, the passage of time. You kind of cheese your way into that. That's why I think, I'm not even kidding about this when I say you can go ahead and legalize it, but this should be the recommendation on a Gregorian calendar. You see what I'm saying? Drugs aren't, they're not, they're only dangerous if you don't understand them. What you don't understand is dangerous, let me put it that way. So if I basically tell everyone, okay, this is the approximation, using numbers, using patterns, using all this, because we're pattern seeking, right? If you, basically, if you're a method, you've leaped over, or leapt, depending on where you're from, leapt over understanding of someone stuck here. You're actually past them because, well, they're stuck. Well, they're stuck in thinking in threes, triangles. Remember, I said it's not impossible using triangles to understand a fifth dimension, but it's hard because then you have to think about the gaps in between. And yeah. And I'm saying on a sphere, the easiest way would probably just be to do this, because it'll curve around and give you a quadrant anyways. See, I don't know. I'm saying you could just decide things are in fours, because that's just how we map things anyways. But I'm saying, don't forget to give yourself at least 3 axes of movement, so you can actually come up off of the sphere from that perspective. You see what I'm saying? But I'm saying it would be in any direction. Living on a sphere makes things hard. makes things a little bit more complicated, which is why I can understand why people even had the slightest second guessing that maybe the Earth is actually flat. But it doesn't seem to be. Anytime I've checked, let me put it that way, every single thing that's been checked, I'm saying, even if it theoretically, hypothetically was, it doesn't have to be forever. It could be a planet. I'm saying you have to understand what all this is to understand how it's a sphere, basically. If you measure a drift, then yes, you're going to be able to, if you have a gyroscope that uses lasers, because remember what I said, lasers are just thermally thermal plus wavelength, I guess I would say. The whole spaghettiification thing. Because if you can still heat stuff up at this level, then it starts to get interesting. But anyways, yeah, I still maintain that schizo is always advocating for C. See, I'm like, most people want to think binary, so they want to think, A, B, C. They want to think of A, B. Sorry, I put C already, but I'm saying everyone always forgets the third dimension. It's like they can only be like, oh, I'm a robot, beep, boop. You know what I'm saying? It's like they're like, beep, boop. They ask you, are you rooting for A or were you rooting for B? I'm like, well, and then I get called this for always saying well, for always being this fence sitter, for always saying, when people pray for their football team to win, and it's like, what do you think? What do you think the logical outcome of that would be? No, just really, just explain it. What do you think the logical outcome of that would be? You know what I'm saying? So, if you start to understand how you can jump timelines, I'm saying you could basically, understanding magnetic forces, you could perhaps if nothing else, at least perceptually, causally connect these. Because I'm saying there are other wavelengths actually stacked up against this. And it's just frequency modulation. Because of the effects of the vacuum fluctuations is because obviously this could be less of a vacuum. I'm saying there are probably whole galaxies where it's way more viscous and there's way less tug from heavy gravitational objects, or it could be vice versa. There could be one galaxy where it's just turmoil constantly of all these interactions, happening and flinging all these objects, all these stars, and like even flinging stars out of galaxies and stuff. I'm saying basically you have to understand the relative. I'm saying you can use curves now instead of having to understand it in like a to the power of 3 manner, a cubed manner. You can curb your logic and start like experimenting with, fractional understanding, I guess, which may appear as incomplete, but it's not. It's saying, I already know this part, kind of. Let me just focus. Let me just modulate. Let me just focus in on the frequency. So I'm saying you can actually do this to skip across. You can, just like you're changing the channel, you can do that in real life. So I'm saying basically reality might start if basically two entities come to understanding and finally meet. They may come to a center point, right? Say these are timelines. They used to be parallel, but just by being close enough, just by sheer force in like an infinite amount of time, seemingly infinite amount of time, they're close enough to where they can agree to touch. You see what I'm saying? Because it's been long enough in the universe, I guess, for it to finally come into existence, let's say. But I'm saying it's not guaranteed to stay coalesced. This is just a stable condition. Who's to say that this Higgs boson, for example, wasn't just resting and that there was another hill that was more. So what it would do is it would start to, if it built up enough potential energy, it would quantum tunnel and then start rolling down to its more natural state. this is the progression of time. This is all that the Mandelbrot is doing. It's just operating at moment per moment, which is, wait, this is a better moment. I'm going here. Wait, this is a better moment. I'm going here. I'm saying may not just be linear. This is just a linear example, but that's what quantum tunneling would be. Tunneling through logic gates. I'm saying, but it's just on such a micro scale that that's what if you look at it from far away, it seems as if it just like there's no way it got that energy. But I'm saying if you zoom in, it's being perturbed constantly, just like in the particles. It's like through every single fluctuation, it's basically being perturbed. And I'm saying if you know the stats of this exotic particle, then you can know the stats of all similar exotic particles that say, so this is particle Q. I'm saying, so you're basically going to know Q over here, even if it's like stats plus 0.0001% difference, right? You understand what I'm saying? I'm like, so they're essentially the same. Like, if you approximate, I'm saying, you know what the best approximation ratio I've found that works? And as long as you keep practicing it, it keeps working. One that's never really let me down is a Fibonacci sequence. Because I'm saying you can, and the thing is, you can, at the end of the day, it's kind of arbitrary too. Because I say 80%, and you can fill me in on the other 20%, and then we can come to 100%. Because basically I'm cheesing logic, and I'm saying, hey, I'm like 80% sure this is the way it's supposed to go. You can be the mirror on the other side and tell me, yeah, it's pretty much that way. And that 20% gap is all that we had to bridge that. But I'm saying it's theoretically arbitrary. You could say, okay, I understand 90% and you only understand 10%. But that means you would have to be so in sync with the other. You would have to expect there to be that mirrored reality on the other side. I'm saying if you descend, or if you ascend quickly, there might not be a mirrored reality to meet you yet. There may not have been enough time in the universe. You're probably looking for something that hasn't yet come to pass. I'm saying you can cheese this by understanding quantum entanglement in the first place. So you can assume, like, if everything just goes as according to the protocol, even deviations, you can tie those back to the main timeline, if you will, and just basically cheese it. Basically, pre-predict ahead and kind of adjust as you go, like as needed basis type of thing, until it meets this checkpoint, this milestone. You know, that's why I said to people, I said in my mind, it's like I start with a goal and I have these different milestones. And it's like people are like, well, how are you gonna do this? Because this is my claim. I'm like, well, you see, I have this theory. And they're like, okay, where's the proof for the theory? I'm like, well hold on. You know? Sheesh. I'm like, okay, and then it's like, if some other force perturbs me, it creates a point right there, and it tosses me off in this direction, and it creates. I'm saying, I may not go, but it's like I'm trying to maintain this homeostasis of trying to get everything done that I want to do, and I'm saying, because once you get the hang of it, even if even if you didn't meet every single you're still, look, this is starting to look like lightning, like Nikola Tesla's like you still stayed within the margins. And I'm saying once you have your claim and it's proven, your theory should graduate to like law at that point, like laws of physics type of thing. You understand? Scientific laws. So I'm saying you can use this claim and back practice all the things you missed. So I'm saying once you prove time travel and you can convince people how to time travel, then you can all start like time traveling to different timelines and start doing like these, because it doesn't violate causality, because it all exists in this like vacuum simulation of sorts, this false vacuum that we live in, which is basically what I'm trying to get people to understand. So throughout my whole life, people are going to ask me when I've proved that time is a product of all these other effects, and I'm like, I don't know. What time do you think it is? You know, like how am I supposed to answer that? If you haven't gone through any of this at all, I don't think you could ever believe me, because you're probably still on this level, like mathematically. And people get mad when I tell them they're down here. But that's just the way it works. I'm saying, so yeah, you kind of have to get over yourself a little bit to kind of understand this. So just real quick, I guess I kind of already covered extrapolation, didn't I? So, Project Starshot by Stephen Hawking. I believe it was 2018, 80 or thereabouts. I'm saying in a hypothetical scenario, if you did Starshot and you had the wavelength problem because you were a different like alien species, shall we say, then you could potentially view, like, say Oumuamua was just like a rocky Starshot. Let's just say in a thought experiment. Let's just say it was. You could, well, honestly, you can analyze the composition of Oumuamua, and it could be reflective, and you could basically deduce, like, you can use a rock as a Project Starshot in and of itself. So I'm saying it's inconsequential whether it was or wasn't. But let's just stick with the hypothetical scenario. They had the wavelength problem. They can't see Earth. It looks like a black hole to them. It looks like a black hole to them. That's a problem. I'm saying, so Gargantuan in 2018, Interstellar, who's to say they weren't just really, really small beings? You know what I'm saying? Were they really small, or were they really big, or were they our size? Can they see? Can they even see? This could theoretically be Earth, and they could just be little tiny micro beings that look like humans. You understand? That's what I say. Once you understand all of time, then you understand it's just a matter of scale. So basically, I'm saying what it seems like is that most humans operate off of beats per minute for some reason or another. That's just the most important thing to them. So they just use, that's how they, because that's I guess blood goes through your body, and it just makes you think that this is the most important thing to your time scale.